Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. We are busy with analytical geometry, grade 10. I'm going to show you now how to prove square. The question says here, prove that ABCD is a square by using the diagonals only. Even you don't say by using the diagonals only, we're going to prove square by diagonals. Why? Because that's the easiest way. And if you have to prove with sides, then you have to prove you have to take all four side gradients, and as well as you have to take the all four sides, apply the distance formula, and you have to take the distance for all four sides, and you have to prove that way. That is a long way. This is the easiest way, right? So now, if there is no diagonal, you can draw the diagonal yourself, but we're going to prove whenever they ask you prove is a square, then you're going to prove with by diagonals. So now this question is a quadrilateral, and we have to prove this is a square. So obviously I need to prove first this is a parallelogram, because this is a parallelogram family. But if they already say this is a parallelogram, for instance, this side is parallel to this side and BC parallel to AD, then we don't need to prove parallelogram, then we only gonna prove square. But in this case, this is not a parallelogram, only a simple quadrilateral, so we have to prove first this is a parallelogram. To prove this is a parallelogram, so we're gonna take the midpoints of AC and the midpoint of BD, and if the midpoint is equal, same midpoints, and then we can say both diagonals bisect each other at O. So let's do first that. So the midpoint, so the midpoint of AC, and we're gonna apply the midpoint formula, which is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So coordinates of A we have 1 and 5, and the coordinates of C we have 3 and -3. So this is my x1 and this is my y1, x2 and y2. I plug all of these value into this formula. So the x1 is 1 plus 3 over 2, and the y1 5, positive and negative become negative, divided by 2. So after I plug these value into this formula, I need to simplify now. So this is gonna be a 2, and this side is become 1. 2 and 1, this is the midpoint of AC. Now I need to take the midpoint of BD. Let's do that. So midpoint of BD, midpoint of BD. B, we got coordinates of B is -2 and 0, and the coordinates of D we have 6 and 2. This is my x1 and this is my y1, this is my x2, this is my y2. Now I need to plug into the formula x1 plus x2 over 2. So the -2 plus 6 over 2, and this side y1 plus y2, 0 plus 2 over 2. I'm going to simplify this one. This is going to be a 2, and that's going to be a 1. So I can see, you can see now, the midpoint of AC and the midpoint of BD, they are equal, 2 and 1, they are same. So which means, so you can see the midpoint of AC and the midpoint of AC and the midpoint of BD, they are equal, same, 2 and 1, so which means they bisect each other at O. So this is a parallelogram, right? So you can see now the midpoint of AC and the midpoint of BD, they are equal, they are same midpoint, 2 and 1, so which mean both diagonals bisect each other at O. So this is a parallelogram. Now we prove this is a parallelogram. Now we need to fulfill the all the conditions for square, which makes this quadrilateral is a square. To prove this is a square, we need to fulfill two conditions: that the equal diagonals bisect each other at 90 degree. So this diagonal AC and the diagonal BD, they are equal and they bisect at each other at 90 degree. To first we need to prove that the diagonals are equal. So we're going to apply the distance formula. Whenever you need to prove that something is equal or sides are equal to each other, so then we have to apply the distance formula. So we're going to take the distance of AC and the distance of BD. So the distance AC, and we're going to apply the distance formula: x2 minus x1 square plus y2 minus y1 square root. Now, so the coordinates of A is, we have 1 and 5, and C we have 3 and -3. This is my x1, y1, x2 and y2. I plug all these values into this formula. So the x2, 3, -1 square, and y2, -3, -5 square, and square root you take, and you need to simplify this one with calculator. So you can plug all these value into the calculator one time, and then you press equal. So 2 times 17 root. So this is my answer, 217 root. So leave in the third form. Now we need to take the distance of BD. So we're gonna take the second diagonals. We're gonna take the second diagonal distance BD. So x2 minus x1. So 6 negative become positive 2 square plus y2 minus y1, 2 minus 0 square, and you take the square root. So plug all these values, you say root, and then you say bracket 6 plus 2, again close bracket, square, and then plus, again open bracket, 2 minus 0 close bracket, again square, and you equal sign. So you can see the answer is gonna be directly 2 times 17 root. 2 times 17 root. Leave in third form. So we prove this, that the both diagonals, they are equal to each other, because the distance of AC and the distance of BD, both they are equal. So we prove the diagonals, they are equal. Now we need to prove these diagonals are perpendicular, they bisect each other at 90 degree. So now have a look. So now you're going to take the gradient of AC and the gradient of BD. So the gradient of AC, y2 minus y1 over x2 minus x1. So this is my x1, this is my y1, x2, and this is my y2. Plug all these values into this formula. So -3 minus 5 over x2 minus x1, 3 -1. So we need to simplify this one. It's going to be -8 over 2, so which is going to be a -4. Right. Now I'm gonna take the gradient of BD. The gradient of BD, y2 minus y1. So the 2 minus 0 over x2 minus x1 6 minus minus become positive 2. So top is 2, at the bottom is 8, which is going to be 1 over 4. Now, so you multiply both gradient of AC, multiply the gradient of BD, and answer must be equal to negative 1. So we got negative 4 multiply 1 over 4, and you can see this is going to be negative 1 also. So left hand side also negative 1. So which means both diagonals bisect each other at 90-degree perpendicular. So we can say AC perpendicular to BD. Now we can say therefore ABCD is a square. So ABCD is a square because equal diagonal bisect each other at 90-degree, or we can say perpendicularly. We prove this is a parallelogram. So we take the midpoint of AC and the BD, and the midpoint is same, so they bisect each other at O. So this is a parallelogram. Then we fulfill the two conditions, which is making a square. So the first, we equal diagonals. We prove the diagonals are equal because diagonal AC and the diagonal BD is the same length. We apply the distance formula. And the last, we prove that the diagonal AC and the diagonal BD, I take the gradient of both diagonals and multiply, and answer come equal to negative 1, which means both diagonals bisect each other at 90 degree. One of the properties of square is equal diagonals bisect each other at 90 degrees. So we prove this is a square because equal diagonals bisect each other at 90-degree perpendicular. Please like and subscribe my channel, and if you have any question, comment below. I will assist you. Have a nice day.